Hi, my name is Jared, and in this bootcamp tutorial we're going to introduce the algorithm framework. The algorithm framework is a scaffolding for solid algorithm design that allows you to separate the concerns of your algorithm into different areas, each with its own speciality. So these core areas are universe selection, alpha creation, the portfolio construction, risk management, and then the execution. In this tutorial, we're going to go briefly into each of these sections and use some of the modules which ship with QuantConnect in the open source project. Our vision is so that you can use these algorithms interchangeably with a uniform API so that you can reuse code between your different projects and in between different parties. So let's get started with a framework overview. The core concept of separation of concerns is a programming concept which allows you to focus your development on each of the class specialities. By focusing this, you can then define an interface and allow your modules to communicate on this well-defined interface. This allows your code to be reused. Here we're going to be setting the basic modules and using the null versions of each of these modules as a way to just get the algorithm to build and run. The null versions of these modules don't actually do anything. They simply pass the data through without impeding it at all. Here we can see the null universe selection model. Here this property sets the universe selection model you'd like to use, and this creates an instance of the null universe selection class. Here we can see the setting an alpha model here, and then we're creating a new null alpha model that we pass in. And here we're going to do the same with portfolio construction. You can see here we're calling set portfolio construction, and then we're passing in the null portfolio construction for it to use. And risk and execution. You'll notice here that we're in our initialize method. We are just setting the defaults for all of these different modules. We don't even have an execution block for the algorithm yet, and we can submit that and see how it goes. Okay, great. Now we're going to go through each of these modules and give you a brief explanation of each one and set it in the algorithm. So the first of these is universe selection. Before your algorithm can generate any trade signals or place any trades, you need to figure out the universe of stocks that you want in your algorithm. The universe selection model is aimed for that. Its core inputs are universe data, and the output needs to be a list of the symbols that you'd like involved in the algorithm. For example, you can imagine a myriad of different universe modules, pharmaceutical stocks, healthcare stocks, agricultural stocks, and each of these are different universe modules that presumably could live in your algorithm. The most basic of these is the manual universe selection model. So you can see here the example. The manual universe selection model simply takes a list of symbols and then sets your universe to be that list of symbols. Here we've got the manual universe of SPY, Equity USA symbol, and we're passing that in as this manual universe. For this task, we need to create two symbols, SPY and bond, and then save them to that list. So we can see SPY. Let's do the same for bond. And the second one is we want to change the universe setting to be daily resolution. So if you note here, this universe settings object is on the QC algorithm base class, and so this resolution property applies to all of the universes that you've added later on in the class as well. So we're asking for daily resolution, and then we pass in the symbols list. Just tidy that up. There we go. Okay, great. On to the next model. The next model in our algorithm is the alpha model. The alpha model takes a list of securities and is intended to generate trade signals on those securities. These trade signals are called insights. They're effectively a prediction about what the asset will do in the future. The prediction has to have a ticker or a symbol about which asset the prediction is about. And then it also needs to have the direction. Is this symbol going to go up or down, along with the magnitude and the confidence? So we provide these helper methods in order to generate these insights, and they're insight.price. And with this helper, you can quickly generate a prediction for that company over a specific time period. So it might not be obvious, but sometimes when you place a trade based on a technical indicator or based on some underlying hypothesis, you're making an implicit prediction that the stock will continue to go up, or a prediction when you short it that it's going to go down. All we're adding here is a little more definition on how long you think that prediction might be, or how far you think that that asset will rise or fall. And using this, institutions can build an expected return of that asset and then use that to score your predictions and understand them on a more detailed level. Okay, so the first thing we need to do is initialize a momentum indicator for each symbol. Let's do that here. And we're going to do that in onSecuritiesChanged. So the alpha model shouldn't make any assumptions about the securities that are going to be traded using the alpha model. This is another example of separation of concerns. So the universe model has selected the securities, and then the alpha model would then build indicators and signals on whatever securities are added to it. So we can see here we're looking at the onSecuritiesChanged event, we're looking at the added securities, and then we're building this momentum dictionary of symbol to the indicator objects based on whatever enters these changed security lists. Now we need to look at that momentum dictionary, find out the assets which have the highest momentum, and sort them. So you can see here we're now moving into our update method. Alpha models have a few different methods that you need to implement. One of them is onSecuritiesChanged, as we've seen, and the other one is updated. So here you're passed in the algorithm and the data from the last slice that came into the algorithm, the last time slice. And now we can look at our momentum dictionary, and then using the indicator's value, we can then sort those momentum indicators. And then finally here it says, return the insights as a group and emitting up for the first item and then flat for the second. So we can use this example code here, which you can see here. And if you note here, I'm using the insight.price to emit the individual insights, and then an insight group to group those two insights together. Underneath the hood, QuantConnect marks them with a name so that those two insights should be traded together. Here the task is asking us to return the grouping of insights with up for the first item and flat for the second. So because these two are ordered, we know the first one will be the strongest momentum and the second one will be the weakest. In order to do this, we can use our ordered collection. And because this is a dictionary, we can access the symbol key here. And then we need to get the symbol value so that we can emit our insight. And to do the same thing for the second. And here we're going to be emitting a flat insight for the second one and an up insight for the first one. In earlier boot camps, we covered a tactical allocation strategy where you invested in the strongest momentum asset. So if you haven't picked it up, here we have the SPY and the bond, and it's the same tactical allocation strategy but implemented in the framework. Here we're emitting, if SPY is the strongest momentum, we're going to emit up for that and liquidate the other asset. It's tricky at first, but you've got to try and disconnect the concepts of trading with the insights. So here we're emitting these predictions, but we're not necessarily requiring that those trades get executed. It's the alpha model's job simply to do the predictions. So let's see how we go. Okay, great. On to the next one. Now you have a group of insights, a prediction about where those two stocks are going to go. Now we need something to generate the targets, the amount of shares that we want to buy. That's the job of the portfolio construction model. In Lean, we've separated this out so that the portfolio construction model can look at the bigger picture and then determine exactly how many shares to buy. So a common application of this is a minimum variance portfolio construction model, which looks at the historical volatilities of the stocks and makes a portfolio which it believes will counteract each other to generate the minimum variance possible. There's a lot of different portfolio construction models out there, and you can generate your own using QuantConnect. But for the purpose of this demonstration, we're going to use the equal weighting portfolio construction model. This means that the model will generate a fixed fraction of shares for each positive or negative insight that comes into it. Insights which are flat or don't have a particular direction or confidence can be downsized to 0. For this one, it's an open source model, and you can view the source code in Lean. You can see the example here. And that logic of doing all of the trading, calculating the fractions, sending those fractions off to be executed, that's all handled with one line of code. So you can see here we've set the portfolio construction to be the equal weighting portfolio construction. So now we have our insights generated and we have a portfolio construction model set. But if you recall from the first task, we still are using a null risk and a null execution model. So nothing should happen. Let's see how we go. Okay, great. On to the next task. Now, we've created an algorithm that's generating signals and generating portfolio targets. Sometimes those targets might be a little bit extreme or might not factor in other risk models that are applied, restrictions which are applied on the portfolio. We've created the risk management model to limit and restrict the output of the portfolio construction model. You can imagine this as a real-time monitoring system, say, for example, to ensure that you're not overexposed in a particular asset or a particular sector of the economy. It blends a little bit with the portfolio construction models, but as long as you use clear separation of concerns to focus this specifically on the risk, it can still be portable between different algorithms. Here we're going to be using a drawdown risk management model. You paste that in here. And using this model, we're setting the maximum drawdown percent per security to be 2%. And this is going to do real-time monitoring of the drawdown that security is experiencing in the market, and then liquidate or control the portfolio targets accordingly. Portfolio targets are the output of the portfolio construction model. A portfolio target is the symbol and the number of shares for the execution model to execute. Here we can imagine that the risk model could detect that the drawdown is more than 2% and produce a new portfolio target which liquidates the holding. Let's submit this, see how we go. Okay, great. On to the next one. All right. Now our algorithm is generating insights. We're generating a portfolio. We're managing our risk. The only thing we haven't done yet is actually place a trade. We're going to use the immediate execution model, which is built into Lean and open sourced, which takes whatever portfolio targets it's given and executes on them immediately. The immediate execution model looks at your existing positions and looks at the portfolio targets and figures out the difference in the target versus what you hold, and then places a trade in order to get there. There are many different types of execution models. Execution models and execution algorithms in general often are aimed at effectively getting the best price for that security. In other lessons, we're going to cover standard deviation execution models or limit price-based execution models. But for the sake of this one, let's just use this immediate execution model to quickly place the trades based on what you'd like to execute. Okay, great. Congratulations. You passed the Algorithm Framework Bootcamp. Thank you very much for watching, and I look forward to seeing you in the next one.